Hello students, in this video we will discuss about availability, dead state, Kelvin-Planck and Clausius statement. Availability, then dead state, and then the two statements of second law of thermodynamics, which are Kelvin-Planck and Clausius statement. So availability is also called as available energy, and unavailability is also called as unavailability. In the operation of any reversible heat engine, we know that a portion of heat supplied from high constant temperature reservoir, or also called as heat source, must be rejected to the heat sink at lower temperature. And for all practical purposes, there is a minimum value of sink temperature which can be considered in most cases. This normally corresponds to the temperature of atmosphere or a large body of water. This is a low temperature reservoir. So, generally speaking, any system employed by the engineers must be operated within the Earth's atmosphere, and the temperature and pressure of the atmosphere impose a limit over the extent to which a given form of energy can be converted into work. And the energy of a system can be divided into two forms. First one is called as the available energy or availability. It is that part of energy which can be converted into work by ideal processes which reduce the system to a dead state, a state in equilibrium with the earth and atmosphere. It means the part of energy which we can convert into work by ideal processes, and that will reduce the system in a dead state. So that part of energy is called as available energy. Second one is known as the unavailability or unavailable energy. It is that part of energy which cannot be converted into work by ideal processes, which reduce the system to a dead state, a state in equilibrium with the earth and atmosphere. Means the part of energy which cannot be converted into work, even by ideal process. We can apply the different process, but the energy that cannot be converted into work. So this energy is called as the unavailable energy. According to definition cited above, the potential and kinetic energies are completely available forms of energies. Potential energy and kinetic energy, these are the completely available form of energy because the elevation and velocity are measured from the source of the earth and the work is done on the earth. We take the reference in the earth surface, so above that surface, these energies are the fully available energies. The part of energy that can be converted into work by the idle process is called as the available energy. And the energy or the part of energy that cannot be converted into work by the idle process is called as the unavailable energy. For example, if we take the example of an IC engine, we use some fuel, either petrol or the diesel. It is having some energy in the form of the chemical energy. So by the combustion of the fuel and by the expansion process in a cycle process, it produces some work or it converts the heat energy into work. The amount of work per cycle we are receiving from an engine, it is called as the available energy. Means by some process, this energy can be converted into work. But After this cycle, we have to exhaust the combustion gases or the smoke into the atmosphere, which is also having some amount of energy. That cannot be converted even by the process. So that smoke or the exhaust gases which are having some amount of energy that cannot be converted into work. It is called as the unavailable energy or unavailability. Now, what is the dead state? The dead state. Generally, the atmosphere of low temperature heat sink is regarded as the most stable state having the following characteristics. Atmosphere or our atmosphere which is surrounded the earth is available everywhere and it is the most stable state which is having the following characteristics. It is homogeneous in temperature, pressure, and composition. It means we can assume that the temperature is overall on the surface is constant. Pressure is 1 atmosphere is constant, and the composition of the atmosphere air is also constant. There is no relative motion in its various parts. We assume that the pressure, temperature, and the composition is constant and there is no relative motion in the atmospheric air. All parts are at the same level. So under such condition, the temperature alone cannot produce any work. So this atmosphere cannot produce any work. Now suppose that any system employed by engineer within the atmosphere has the following characteristics. Atmosphere alone cannot produce any work, but because it is at rest with the atmosphere. If any system employed by an engineer, if it is at rest with the atmosphere, means it can produce no work. If it is in equilibrium with the atmosphere regarding pressure, temperature, electricity, magnetization, etc., under the above conditions, no work will be obtained from interaction between the system and surrounding. Because the surrounding or atmosphere is considered as a dead state. Dead state means when its capability to produce work ceases. So it's called a dead state. It can produce no work at all if any system is employed within the atmosphere. Therefore, the dead state of a system is defined as the state of stable equilibrium of the system. System will be in the state of equilibrium, still equilibrium within the atmosphere. That is, its capacity to do work ceases and its available energy is zero. So Earth and atmosphere are regarded to be in stable states. The following conditions specify the dead state of a system. The system should be in the stable and inert phase. System will be in the stable condition and in the inert phase. Thus, any phase change or chemical reaction is not possible. There is no chemical reaction or phase change will be there. The system should have pressure and temperature equal to that of the atmosphere. The system will have pressure as well as temperature that will be equal to that of the atmosphere and its elevation and velocity should be zero. If we write mathematically, then final pressure equal to the atmosphere pressure, final elevation equal to zero, final temperature equal to atmospheric temperature, and final velocity will be that is also equal to zero. Here P naught, T naught are the atmospheric pressure and temperature, or the pressure and temperature of the system which is now in the dead state, or pressure and temperature of the heat sink. Now there are two statements in the second law of thermodynamics. The first statement is known as the Kelvin-Planck statement. This statement says it is impossible to construct an engine which will work in a complete cycle. It is impossible to construct an engine which will work in a complete cycle and will produce no other effect except the rising of a weight and cooling of a heat reservoir. It means no engine is possible which will work in a complete cycle and that will produce no other effect except the rising of a weight and cooling of a heat reservoir. In other words, no process is possible whose sole effect is the removal of heat from a single thermal reservoir at an uniform temperature and the performance of an equal amount of work. So these two statements are actually the same. In the first statement, it is impossible to construct an engine which will work in a complete cycle and produce no other effect except the raising of a weight and cooling of a heat reservoir. So cooling of a heat reservoir means we are taking some heat from the heat source. Raising of weight means we are producing the work. So we are taking some heat and we are converting into work. This type of engine is not possible because we are completely converting heat into the work. And the no process is possible whose sole effect is the removal of heat from a single thermal reservoir at an equal temperature and the performance of an equal amount of work. The statement, which is the second statement, it also says the same. We are removing heat from a single thermal reservoir and performing an equal amount of work. So heat and work here are being uh, are equal, being converted one into the other. So this type of engine or this type of process is not possible. Here the engine is only interacting with the one reservoir. Here you can see this is the heat source at temperature T1, which is taking 100 kilojoule of the heat from the heat source and will producing the same amount of the work. So it is interacting, it is taking heat from the heat source at an infant temperature, which is taking taking 100 kilojoule of heat and producing the same amount of work. So the here the heat is being converted into the work fully. It is not possible. In the second case, if we take 100 kilojoule of heat from the heat source, we produce 40 kilojoule of work and reject 60 kilojoule of heat. This case is possible, right? This case is not. This case is not possible. This is not a practical case. This is not possible. Now, second one is the Clausius statement. So this says it is impossible to construct a heat pump which operating in a cycle. Actually, Clausius statement says about the heat pump which operating in a cycle will remove heat continuously from a lower temperature reservoir and transfer to a higher temperature reservoir without any amount of external work being done on it. Which means a heat pump which will remove from the heat from the low temperature reservoir and will transfer or pump it to the higher temperature reservoir without requiring any external or additional amount of the heat to it. Or no process is possible whose sole effect is the removal of heat from a reservoir at lower temperature and the absorption of equal amount of heat by a reservoir at higher temperature. The process is not possible. It will remove heat from a low temperature reservoir and will transfer it to the higher temperature reservoir without taking any amount of extra energy. Or we can say, the third statement, heat itself cannot flow from a colder body to a hotter body. It's the heat is flowing from colder body to hotter body automatically. This case is not possible. So these are the statement of the second law of thermodynamics. Thank you.